Hello, everyone. This is part two of a chapter 13 lecture. In this session, we will examine the concepts of average cost and the marginal cost. First, we will learn how to calculate average cost and marginal cost, and then we will learn how to interpret average cost and the marginal cost. Okay, let's use our lecture note. In the previous session, we learned the total cost is made up of fixed cost and variable cost. So total cost of production is made up of fixed cost and the variable cost. And when you produce output, some expenses do not change. In other words, some expenses remain the same even when you increase the level of output or decrease the level of output. Simply put, whether you increase more of a product or less of a product, some expenses do not change. We call such expenses fixed cost. Examples include such as what? A monthly property rent and property tax or some insurance premiums. They do not change whether you have what? Large business volume or small business volume. But on the other hand, some expenses will change. Some expenses will grow as you produce more output. And those expenses will be smaller, will decrease as you produce lower the level of the output. And we call such expenses variable cost. Examples include, for example, labor. To produce more output, you need to use more labor. So you got to spend more money on labor. So typically, the labor cost will increase as you produce more output, and the labor costs will go down as you produce less output. Well, it does take a lot of materials to produce the product. So as you increase the production of a good, then you're going to end up spending more money on raw materials and also utilities. So those expenses are called what? Variable cost. Now, then how do we figure out the average cost? So here, we're going to first examine average total cost. Now, from now on, for just convenience, we're going to denote average total cost by ATC. So ATC means average total cost. Now, remember this. In economics, whenever we define average of something, we always interpret average in relation to quantity or level of output. In other words, we understand average of something as what? Now, in the context of what? Quantity. So here, when we say average total cost, what we mean by average here is when you produce given amount of output, okay, and then per unit, how much does it cost? So average is what? Interpreted in the context of what? Quantity or units. So simple definition of average total cost is what? So So average total cost is, so here, what do you see here? Average and total cost, right? So average and total cost, right? So now average means what? I said we're gonna interpret it in the context of a quantity. Okay, so and then in the context of what? Quantity, but the what average are we trying to figure out here? Total cost. So simply total cost divided by, we're going to understand this in the context of a quantity. So we're going to divide this by quantity. Okay. So simply this is what? Total cost divided by the quantity of what? Output. Okay. So use just simply what? Divide the total cost of producing a given amount, okay, by the quantity. So what does this mean really then? Okay, let me use a different color here. So here, what it means is, so what does ATC mean? Okay, how should we interpret an ATC? So average total cost means, this means when you spread total cost evenly over all the units produced. Okay, so when you spread the total cost evenly over all the units produced, then how much does the typical unit cost? So that's what the meaning of what average total cost. You may wonder, hey, all we needed to know is a total cost. Why do we care about average total cost? Well, it is sometimes handy to know how much a typical unit cost instead of what? Total cost. So how can we calculate the average total cost? It's very simple. You divide the total cost by quantity. And then what does this mean? It means what average total cost tells us is when you spread total cost evenly over all the units produced, then how much does the typical unit cost? That is the meaning of average total cost. Now, let's go back to the definition of total cost. The total cost is what? Fixed cost plus variable cost, right? So when you divide the total cost, actually what you do is simply this. So here, total cost is equal to fixed cost plus variable cost. So when you divide the total cost by Q, when you divide left-hand side, total cost by quantity, then what? You can divide both sides by the same number, same quantity, so what? Equality will hold. So on the right-hand side, you also divide each term by quantity. And then the first term on the right-hand side is what? Fixed cost divided by Q. So we divided the fixed cost by Q. And we call this average fixed cost. So now again, you don't really have to memorize this. So here, average fixed cost is what? We have here what? Two words here. One is average. And then fixed cost. So what did I say? In economics, average is what? Interpreted in the context of a quantity. So simply what? Whenever you see average here means what? That means you divide what follows by the quantity. So you simply divide fixed cost by the quantity. Okay. In other words, when you spread all the fixed expenses over all the units you produce, then how much fixed cost does the typical unit incur? That is your average fixed cost. Okay. Now, finally, what is your average variable cost? That is what? The second term on the right-hand side. So when you divide the total cost by Q, you divide the fixed cost by Q plus variable cost by Q. So it's simple. This is what? You divide all the variable expenses by the quantity. And we're going to denote this by what? Simply AVC. So here, again, AVC is what? Here, A means what? Average. And the VC means what? Variable cost. So simply, now what? Average means what? We understand something what? In the context of a quantity. So you divide variable cost by quantity. So that means you produced a given amount. Then if you spread all the variable cost over the units you produced, then what? How much cost variable expense does the typical unit incur? That is what? Average variable cost. And finally, now what do you know? We know here total cost is a fixed cost plus variable cost, right? Now, we divided both sides by the same number, same quantity. Then this equality will remain the same, right? And then, let me use a different color here. So here, on the left-hand side, when we divided total cost by quantity, now we call that what? Average total cost. And when we divide fixed cost by quantity, we call that average fixed cost. When we divide variable cost by quantity, we call that average variable cost. Okay, so total cost is equal to the sum of FC, fixed cost, and variable cost. So we divide both sides by the same quantity, so what? Equality should remain the same. So now what do we know? Total cost is a fixed cost plus variable cost, and average total cost is what? Equal to the sum of average fixed cost and average variable cost. Okay, so now let's apply our understanding to complete this table. So first, now the first column shows levels of output. Okay, then second column is what? Fixed cost. And the third column shows variable cost. And the fourth column is what? Total cost, of which is total cost is what? Simply fixed cost plus variable cost. Okay. So can you confirm that? Look here. Total cost when you produce nothing. Of course, what did we learn last time? Variable costs are what? Expenses that increase when you produce more output. So that means when you produce no output, variable cost is always zero. And the fixed cost never changes. Whether you produce a zero output or 100 units, 200 units, fixed cost do not change. So you can see it here along the second column. As output increases, does fixed cost increase? No, it remains the same. That's why we call this fixed cost. However, variable cost does grow as more output is produced. Okay, so when you produce 100 units, variable cost is 40. But if you produce 200 units, then what? Variable cost is now what? Greater than before, just 64. Okay, so first we confirm that total cost is equal to the sum of a fixed cost and variable cost. We can easily confirm that in this table. Now, so let's figure out the average cost. We have a family of average cost here: average fixed cost, average variable cost, and the average total cost. So first, let's figure out average fixed cost. Now, the first cell, well, we cannot fill out the first blank here. Why? Because, look, average fixed cost is what? Fixed cost divided by Q. We do know fixed cost is 0. But we cannot divide something by 0. Mathematically, it just is not defined. So we're going to leave the first blank cell as it is. Okay. Now, then when you produce 100 units, well, fixed cost is still 100. So what's the average fixed cost? Simply what? Fixed cost 100 divided by quantity 100. So average fixed cost is equal to 1. That means when you produce 100 units, fixed cost is 100. So you spread $100 over 100 units produced, then what? Per each unit, the what? The typical unit, what incurs the what? The average fixed cost of $1. Okay. So likewise, now what about the average fixed cost when you produce 200 units? So now you're going to spread $100 over 200 units. So that means you divide the same fixed cost by 200 units. So then now what? It's going to be 50 cents. Okay, which obvious. You spread $100 over 200 units evenly, then for each unit, typical unit, average fixed cost is what? 50 cents. Now let's do it here. Okay, what if you produce 300 units? So we're going to divide $100, the fixed cost, by the quantity 300. So it'll be what? About 33 cents. And likewise, if you produce 400 units, okay, so we're going to divide fixed cost by the quantity 400. So now what do you get? 25 cents. And finally, the same fixed cost 100 is divided by 500 units. Then what? Per unit, typical unit incurs what? Average fixed cost of what? 20 cents. Okay. So here now we learn a very important lesson. Our first finding here is what? Average fixed cost always declines as more output is produced. I mean, it is obvious because fixed cost does not change with the level of output. So as you increase, in this example, as you increase the output from 0 to 100, 100 to 200, and all the way up to 500 units. Does fixed cost change? No, fixed cost remains the same at the 100. So to figure out average fixed cost. We just divide the same fixed cost by a greater and greater output. So what? It only becomes smaller and smaller. So average fixed cost always declines as more output is produced. Okay, that's our first finding here. Now, let's figure out average variable cost. Likewise, the first blank cell, okay, we're gonna leave it as is. We cannot fill in the first cell here. Why? Because average variable cost is variable cost divided by Q. You cannot divide something by 0. So when output is 0, average cost is not defined simply. Okay, so we're gonna leave it as it is. Okay, so now when you produce 100 units, what's the average variable cost? Simply variable cost 40. Okay, we're gonna divide this by the quantity. So 40 divided by 100 is what? 40 cents. Now, what if you produce 200 units? What's the average variable cost? Now, remember that variable cost does increase as more output is produced. So now what? At the 200 units, when you produce 200 units, variable cost is now what? 64. So 64 divided by 200, okay? It's going to be 32 cents, okay? Now, when you produce 300 units, now variable cost is now 78. So all you needed to do is what? Variable cost of 78 divided by 300. So that is, looks like 26 cents. Let me just confirm it. 78 divided by 300 is, yes, 26 cents. Okay. Now, if you produce 400 units, okay, then variable cost is now what? Even greater, 88. So 88 divided by 400, so it's going to be 22 cents. Now, finally, if you produce 500 units, then variable costs rise to 100. So 100 divided by quantity 500 is now 20 cents. So in this example now, what do you see? As you produce more output, variable cost does increase, does grow with the level of output. But somehow average variable cost keeps falling as you produce more output. Is it always true? Not necessarily. Okay. And somehow in this example, average variable cost is falling, decreasing as you produce more output. That's because variable cost increased as you produce more output, but it didn't increase fast enough. Okay. But is it always true? Not necessarily. Now, average fixed cost always declines as more output is produced. That's always true. Why? Because fixed cost does not change. And you divide the same fixed cost by greater and greater output. So average fixed cost is always declining as more output is produced. But in this example, it appears that average variable cost also declines as more output is produced. But this is only true in this example, but you cannot generalize this finding, okay? Now, average total cost. So finally, average total cost is what? Total cost divided by Q. As usual, at the zero output level, average cost is not defined. So we're gonna leave this first cell blank, okay? Now, once you figure out average fixed cost and average variable cost, then what? You can figure out average total cost in two ways. First, as usual, you can divide total cost by the quantity. Let's do it. So total cost of producing 100 units is what? 140. So you can divide the total cost by the quantity. And then it's what? 1.4. That means when you spread the total expense, total cost over 100 units produced, okay, evenly, then what? The typical unit costs $1.40. Now, another way to figure out average total cost here is what? Remember, average total cost is what? Average fixed cost plus average variable cost. So let's see. When you produce 100 units, average fixed cost is 1, average variable cost is 40 cents. So average fixed cost plus average variable cost is what? Still $1.40. So you can figure out average total cost either way, simply by dividing total cost by the quantity produced, or by adding up average fixed cost and the average variable cost, either way. Okay. Now here, we already know average fixed cost and average cost and the average variable cost. So what? We can just add them up. So average total cost of producing 200 units is what? Average fixed cost plus average variable cost. So it'll be simply 82 cents. Okay. Or you can actually what? Confirm this. For example, 164 total cost divided by 200 units, then what? You still get 82 cents. Okay, either way. And then now, when you produce 300 units, average total cost is what? Well, let's add this up. Then what? It's going to be 0.59 cents. Now, if you produce 400 units, then average total cost is what? About 47 cents. And finally, if you produce 500 units, then average total cost is what? 40 cents. Okay. All right. So that's the average cost. Okay. Now, we're going to explore another interesting cost concept called marginal cost. So here, marginal cost. So what do we really mean by marginal here? So marginal means what? A small change, okay? Marginal means what? A small incremental change, okay? Or more practically, you can define marginal as what? Simply, you can interpret it like this. One more, okay, or one more unit, okay? So marginal cost means what? When you produce more output, how much additional cost do you have to incur? Or how much additional cost occurs? That's the marginal cost, okay? So here, the textbook definition of marginal cost is what? A change in total cost. So here, a change total cost divided by a change in output. So that means what? When you increase the output, when you produce more output, that's change in output, then, well, we do know fixed cost does not change, but as you produce more output, variable cost is what? Always what? Increasing as you produce more output, right? So we do know total cost is fixed cost plus variable cost. As you produce more output, fixed cost remains the same, but as output grows, what happens? Fixed cost remains the same, but as output grows, variable cost increases. Since total cost is a fixed cost plus variable cost, so what? Whenever variable cost rises, then what? Total cost will also rise. So simply we measure here a change in output and then how much additional cost occur. So we measure change in total cost. So we divide change in total cost by change in output, and we call this what? Marginal cost, and then we simply denote this by MC. Okay. All right. So first we're going to learn how to compute marginal cost. Okay. Now before we do that, so let me just write down here another important finding. Variable cost always increases as more output is produced. Now we can confirm this here, okay? Along the third column here, as output grows, variable cost always increases, okay? I mean, it's just common sense. How can you produce more output without having to incur more cost, okay? Now, here's the tricky part. What if I say average variable cost always increases as more output is produced? Now, this is not true, okay? Why? As you produce more output, now variable cost will increase. You have to spend more money on the inputs. But average variable cost does not necessarily increase. Does not necessarily what always increase or always decrease. It depends on what? How fast the variable cost increases as output increases, okay? So we can say variable cost always increases as more output is produced. Yes, true. But can we say average variable cost always increases as more output is produced? No, this is not true, okay? All right, keep that in mind. So here, now, marginal cost. A change in total output, a total cost divided by change in output. So let's figure it out. Again, the first cell, we're going to leave it blank because when you produce a zero output, then what? There's no change, okay? So now, when you increase output here, in this example, when you increase your output from 0 to 100, what's the change in quantity? It's 100, right? And then what's the change in total cost? When you produce no output, total cost is what? The same as a fixed cost because there's no variable cost. Now, when you produce what? 100 units, then what? Total cost increases from 100 to 140. Okay, so when you do that, what's the change in total cost? Here, change in total cost is what? 40. Okay, so now go back to the definition. A change in total cost divided by change in output. So 40 divided by 100. So that means what? When you produce 100 more units, total cost increased what? By 40. So that is what? 40 cents. Okay. Now, suppose now you further increase the output. Now this time from 100 to 200 units. So what's the change in quantity? It's still 100. From 100 to 200. So change in output is 100. Now cost, change in total cost is now what? Well, as you produce more, total cost increased from 140 to 164. So here change in total cost is what? The difference between these two. So 24. So 24 divided by change in quantity 100 is now what? 24 cents. Now here, if you produce now what? 300 units. What's the change in quantity? Well, previously what? You produced the 200 units. Now you produce 300 units. So change in quantity is still 100. And then total cost also increases from 164 to 178. The difference here is what? So change in total cost is what? 14. So we're going to divide change in total cost 14 divided by change in quantity 100. So it'll be 14 cents. And then now, if you produce a total of 400 units, then what's the change in quantity? Well, previously you produced the 300 units. Now you produce 400 units. Change in quantity is 100. And the change in total cost is what? Only 10 here. So change in total cost divided by change in quantity. So it gives you what? Marginal cost of 10 cents. And here, finally, if you produce 500 units, that means you increase the output by 100. Your previous output level was 400. Now you produce 500 units. So what? Change in Q is what? The difference, 100. And the change in total cost is what now? 12. So 12 divided by 100. So here change in total cost is 12. So 12 divided by 100 is now what? 12 cents. Okay. So that's how you figure out marginal cost. Now, before we move to the next example, I would like to direct your attention to this. So here we calculated what? Marginal cost as what? The change in total cost divided by change in quantity. Okay, now, but we do know total cost is a fixed cost plus variable cost. Fixed cost does not change, right? So if there is any change in total cost, that must be what? That must be stemming from a change in variable cost. So from this, we can tell change in total cost is always the same as a change in variable cost. Let's confirm. When total cost increased from 100 to 140, there was no change in fixed cost. So what was the change in variable cost? Variable cost increased from 0 to 40. So change in variable cost is 40. Exactly the same. Okay. So here change in variable cost is what? 40. Now, here this time, when you increase output from 100 to 200 units, what's the change in variable cost? Change in variable cost is what? 24. That's exactly the same as what? Change in total cost. Okay. So we do know change in variable cost is exactly the same as a change in total cost because the fixed cost does not change. So then we can define marginal cost also as follows. Change in variable cost divided by change in quantity. Why? Because change in total cost is always the same as a change in variable cost. Okay, keep that in mind. So you can figure out marginal cost in two ways. First, a change in total cost divided by change in Q, or a change in variable cost divided by a change in Q, because a change in total cost is the same as a change in variable cost. Okay, now example 2. Okay, so here, now this example is a slightly different than the first example. Why? In the first example, each time output increased exactly by the same amount, 100, 100. So change in output was always equal to 100. Okay. Here, we just assumed output increases by 100 units each time, but that may not be realistic. Okay. So now, in example 2, so here output bushels of wheat increases what? From 0 to 1,000, 1,000 to 1,800, 1,800 to 2,400. See here? Output increases the what? By different amounts here. Okay. Then here we have a total cost. First, we can confirm here. As the output increases, total cost increases. Why? Because of variable cost increases, right? Now, so let's figure out marginal cost here, okay? Now, marginal cost, so let me use a different color here. So first, when you increase output from 0 to 1,000, what's the change in output? 1,000, right? Then what's the change in total cost? Total cost increased from 1,000 to 3,000. So change in total cost is what? 2,000. So simply change in total cost divided by change in Q is what? $2,000 divided by change in quantity, 1,000 is now what? $2. Now you increase output from 1,000 to 1,800. So change in output is 800. And total cost increased from 3,000 to 5,000. So change in total cost is 2,000. So change in total cost over change in Q. So 2,000 over change in quantity 800, and that gives you what? $2.50. Okay, and you can calculate the marginal cost exactly the same way by dividing change in total cost by change in quantity. Okay, all right. Now, in this example, so what's the marginal cost when you produce 1,000 bushels? So at the quantity 1,000 here, okay, quantity 1,000 here, what's the marginal cost? That means when you look at always the previous output, previous level of output was what? 0. So when you produce 1,000, then what? Change in quantity is 1,000, right? So change in quantity is 1,000, and then change in total cost is what? 2,000. So change in total cost divided by change in Q is what? 2,000 divided by 1,000 units, so it is $2. Okay, that's what we figured out just a minute ago. Then, what's the marginal cost at the 2,800 units? So 2,800 units. So when you produce 2,800 units, what's the marginal cost? Okay. Now, go back to the what? The definition of a marginal cost here. Marginal cost means what? When you produce one more unit, how much does the last unit cost? Okay, so one more unit here means what? Simply means when you produce one more unit, how much does the last unit cost? So that's another way to interpret marginal cost, okay? So let's go back here. When you produce 2,800 units, okay? So first you need to figure out change in quantity. When you produce 2,800 units, now marginal cost is all about a change in total cost over a change in quantity. So you have to figure out a change in quantity. So when you produce 2,800 units, so to figure out the change, you have to go back the previous output level. Before you produce 2,800 units, what was the previous output level? 2,400, right? So the difference here is what? 400. So change in quantity is 400. And change in total cost is, again, when you produce 2,800 units, total cost is 9,000. Then to figure out a change in total cost, you have to find out total cost at the previous output level. That was what? 7,000. So change in total cost is 2,000. Okay. So change in total cost is 2,000. So marginal cost is change in total cost over change in Q. So what? $2,000 divided by 400, and it gives you what? $5. Okay. So here we can confirm this. Okay. Now next question is very important. How should you interpret the marginal cost? Well, now we know how to calculate the marginal cost, but what's the meaning of that? For example, when you produce 1,000 units, marginal cost is $2. What does that mean? Or when you produce 2,800 units, marginal cost is $5. What does that mean? Okay, so we're gonna use a specific example here to have what? A correct understanding of the marginal cost concept. So here, when you produce 2,800 units, so what does this mean? So this means, now what? Look here. When you produced what? First time, here, look at the interval. When you produced 2,400 units, total cost was 7,000. Okay, so at the quantity output level of what? 2,400, total cost was 7,000. And at the quantity at the output level of what? 2,800, total cost is what? 9,000. So here, the difference in quantity is what? 400. Difference in total cost is 2,000. So we divided what? 2,000 by 400. So that's $5. Okay. So one of the most common mistakes students make when they interpret marginal cost is like this. The wrong interpretation. I'm giving you an example, okay? To produce let me put it this way, erase. Okay. To produce 2,800 units more. Okay. Or to produce additional 2,800 units. Okay. It costs, for example, $5 here. No, this is wrong. Okay. Then what is the right way to interpret marginal cost here? Now look here. We already know the marginal cost when you produce 2,800 units is $5. So what does this mean? Means what? The right way to understand, interpret the marginal cost is this. Look here. When you produce 2,800 units, What was the previous output level? That was 2,400. So when you produce 2,800 units, that means what? You increased your level of output by 400, right? Change in quantity to 400. So that means when you increase the output by 400 units, okay, when you increase the output by 400 units, then what? Total cost what? Increased by $2,000, right? Total cost increased from $7,000 to $9,000, right? So that means what? So marginal cost, the meaning of the marginal cost here, $5, is when you increase the output by 400 units. Each of those additional 400 units costs how much? $5. That's what it means. Look here. In this example, change in quantity is what? 400. Change in total cost is what? 2,000. So you divide the change in total cost by change in quantity. That's how you got $5 here. So what it means, what $5 marginal cost means is what? When you increase the output by 400 units, change in total quantity, when you increase the output by 400 units, total cost increased by 2,000. So you divide the what? 2,000 by 400, that gives you $5. So that means what? Each of those additional 400 units cost $5. So you increase the output by 400 units, okay? 400 units more. And each of these 400 units costs you what? Additional $5. So then additional total cost is what? 400 times 5 is what? $2,000. And that is exactly what? The difference in total cost, a change in total cost, okay? So the right way to interpret marginal cost is this. Each of those additionally produced units, each of those additional units cost how much? Or you can say the last unit, when you produce up to 2,800 units, how much does the last unit cost? Okay, so when you produce what? More and more units, how much did the last unit cost? That's the marginal cost. So in this example here, we increased the output by 400. In this example, the marginal cost was 5. What does that mean? That means what? Each of those additional 400 units, each of those additional 400 units cost you what? $5. That's the marginal cost, okay? All right. So now example 3 is now what? Now here we will test our understanding of average cost concept and the marginal cost concept. Okay, it looks pretty challenging, but it's not. Okay, so there are so many blank cells. How are you gonna complete this table? Always remember this. First, the fixed cost does not change, and variable cost is 0 when output is 0. That's what the first step you need to take. Okay. Remember, fixed cost does not change when output changes. Second, the variable cost at the 0 output is always 0. That's the first step. You gotta put that right foot forward. Okay. So that's the first. So at the 0 output level, variable cost is always 0. Okay. Now, we know total cost is fixed cost plus variable cost. right? So here we already know total cost is what? 12. This is 12 is what? Fixed cost plus variable cost. Now we do know variable cost is 0. So fixed cost should be here 12. Okay, so once you fill in these two cells, then what? Now it gets much easier. Does it fix the cost change as you produce more output? No. So simply what? Always what? The second column is what? Filled with the same fixed cost, 12 and 12. Okay, now, well, then when you produce 1 unit, total cost is, we don't know, but we do know fixed cost and variable cost, right? So 12 plus 1 is what? 13. Okay. Now, this one is a little challenging, okay, but you can do it. Well, we do know fixed cost. We do not know variable cost or total cost. But we are given this. Average variable cost at quantity 2 is 1.5. Okay. Now try to recall the definition of average cost, variable cost. We do know average variable cost is what? Variable cost divided by Q. So we are given average variable cost. Average variable cost is $1.50 and the quantity is 2, but variable cost is not known here, unknown. So here, then the variable cost should be what? $1.50 times 2 is what? $3. What number should you have in this box to have what? Average variable cost of $1.50. It's got to be $3. Okay, simply what? Using this definition, we can easily figure this out. Okay, now this is the most challenging part in this example. Okay, so you do not know variable cost, but you do know average variable cost. Then what? You can always figure out variable cost what? By multiplying average variable cost by quantity. Okay, so $1.50 times 2 is now what? 3. So variable cost is 3. Then now you do know fixed cost and variable cost, so what total cost should be 12 plus 3 is what? 15. Okay. Now, when you produce 3 units, well, you do know fixed cost, but there are a lot of what? Blank cells. But the only other information you have here is what? Marginal cost is 2. What does marginal cost tell you? When you increase your output from the previous output level, then what? Additional cost is what? $2. So here, what was the previous output level? Previous output level is what? 2. This is the previous output level. Now you produce 3. Okay, so you produce 1 more unit, right? So you produce 1 more unit. Then total cost increased by how much? 2. Now recall this. Marginal cost is what? Change in total cost over change in Q. So in this example, when you increase the output from 2 to 3, what's the change in quantity? 1. Change in total cost is what? Well, we know marginal cost is 2. So that means what? Change in total cost must be what? 2. Okay. So here, as you increase the output by 1 each time, your marginal cost increased by 2. That means what? Total cost increases by what? 2. At the previous output level, when you produce the 2 units, total cost is 2. Now, when you produce 1 more unit, total cost increased by how much? 2. So 15 plus 2 is now what? 17. Then you do know fixed cost and total cost. Then what's the variable cost? Because the total cost is a fixed cost plus variable cost. Total cost is 17. Fixed cost is 12. then what? Variable cost must be 5. Okay. So now next example is straightforward because you do know both fixed cost and variable costs. So 12 plus 7 is what? 19. Now next example is also straightforward. You do know fixed cost and total cost. Then variable cost is what? Fixed cost plus something is 21. So the difference is what? 9 here. Okay. So now what about quantity when you produce 6 units? Well, it's again, we already did it. When output increases by 1, we need to know total cost changes by how much. That's exactly the marginal cost concept. When you produce 6 units, marginal cost is 2. What does that mean? That means when you increase the output by 1 unit, that additional unit costs you what? Additional $2. So total cost changes by $2. Total cost increases by $2. So 21 plus 2 is what? 23. Now you know fixed cost and variable cost. So the difference here is what? Variable cost is what? 11. Now when you produce 7 units, well, you are given variable cost. So what? 12 plus 13 is what? 25. That's the total cost. Now the last one, when you produce 8 units, here we do not know variable cost or total cost yet, but we are given average total cost. So average total cost is given. Average total cost is what? Total cost divided by Q. So we already know the value of average total cost. That is 3.375. That number is given. What's the quantity? 8. What's the total cost? We do not know. So simply the total cost is what? Simply here, total cost is what? Average total cost times quantity. Likewise, the value in this box is what? Average total cost of 3.375 times 8. So that is 3.375 times 8 gives you what? 27. So total cost is 27. Then variable cost is what? The difference between these two. Okay. So total cost is a fixed cost plus variable cost. So total cost is 27, fixed cost is 12, and then variable cost, it should be what? 15. Okay. So now we completed what? The first half of this the table. Now we do know at each individual output level, we know fixed cost, variable cost, and the total cost. But the rest is straightforward. So first, average fixed cost. Fixed cost 12 divided by quantity. So 12 divided by 1 is 12. Now, when you produce 2 units, then what? The same fixed cost, but 2 units this time. So it'll be 6. And average fixed cost when you produce 3 units is what? Fixed cost 12 divided by 3 is 4. And when you produce 4 units, average fixed cost drops to 3. And when you produce 5 units, it's what? 2.4. When you produce 6 units, it's a 2. When you produce 7 units, let's see, when you produce 7 units, it's about 1.71. And finally, 12 divided by 8 units is what? $1.50. Okay, so what do you see? Can you confirm that average fixed cost always declines as more output is produced? Yes, that's true. Now, average variable cost is simply variable cost divided by Q. So 1 divided by 1 is 1. Here, let's confirm this. Variable cost of 3 divided by 2 units. So what? $1.50. That's true. So 5 divided by 3 is $1.67. And 7 divided by 4 is $1.70. If you round up, it's gonna be $1.75. Oh, no, you don't have to round it up. And 9 divided by 5 is 1.8. And 11 divided by 6 is 1.83. And 12, no, 13. Okay, so let me erase it here. Okay. Variable cost is 13. So 13 divided by quantity 7 is about $1.86. And finally, 15 divided by 8 is $8.75. Okay. All right. So once you figure out average fixed cost and average variable cost and what average total cost is what, you just add them up. So 12 plus 1 is here, 13. 6 plus 1.5 is $7.50. This will be $5.67. Here, $4.75. And this will be $4.20. And this will be $3.83. And this one is now what? $3, approximately 57 cents. And $1.50 plus $1.875 is what? 3.375. Okay. Now finally, the marginal cost. Marginal cost is what? Change in total cost over change in Q. Now in this example, it's straightforward. Why? Because each time what? Quantity increased what? Always what? By 1 each time. Okay. So change in Q is what? Always equal to 1. Okay. In this particular example. So all you need to do is what? Just look at the total cost. So marginal cost is change in total cost divided by change in Q. In this example, it's very easy because a change in quantity output is always equal to 1. So in the definition, denominator is always equal to 1 in this example. So all you need to do is what? Just look at the change in total cost. So total cost increased what? By 1. So 1. Total cost increased the what? By the 2, right? Here, 13 to 15, so 2. And the 15 to 17, 2. And so in this particular example, marginal cost is what? Increasing by 2 each time when you produce what? More than 1 unit, okay? So it looks very challenging, but actually it is not, okay? So the first couple of steps, very important when you try to complete a table like this. First thing is what? Variable cost at the 0 output is always equal to 0. And the fixed cost is what? Always the same. Once you do know, what you understand this, then what? The rest is what? Pretty much straightforward. Also remember, whenever you are given average variable cost and quantity, you can always figure out what? Variable cost. Okay, why? Because once you know average variable cost and variable quantity, then what? You can go back. You can just simply reverse the process. Variable cost is what? Average variable cost times Q. And if you know the average total cost and quantity, you can always figure out what total cost as well. Okay, average total cost is what? Total cost divided by Q. Just to reverse the process. So total cost is what? Average total cost times Q. Then you can complete any kind of what table like this. All right. Okay, this will conclude our session 2, and we will continue to discuss the rest of the topics in the following session. All right, thank you.